Puberty. Wow. It's probably one of the biggest, most awkward, and, let's be honest, weirdest transformations any of us will ever go through. But underneath all those growth spurts and voice cracks, there's this incredibly precise and fascinating biological process. So in this explainer, we're going to pull back the curtain and break down the science of what's really going on.
We've all been there, or we're headed there. That time when your body just seems to have a mind of its own, right? But what actually kicks the whole thing off? What flips that one switch that starts this massive chain reaction? That's the question we're going to get to the bottom of.
Okay, first things first, let's get on the same page with a solid definition. What is puberty from a purely scientific point of view? Because it is so much more than just an awkward phase, it's a massive biological turning point in our lives.
At its absolute core, puberty is the process that takes a child's body and matures it into an adult body, one that's capable of reproduction. You can really think of it as the body's pre-programmed transition from childhood to adulthood.
So, when does all this get started? Well, the timing can actually vary quite a bit. For females, you're typically looking at a window between 8 and 14 years old. For males, it's usually a little later, kicking off somewhere between 10 and 16. The key thing to remember here is that these are just averages. Everybody's personal timeline is totally unique.
So, we've got the what and the when, but what about the how? How does this all happen? Well, the answer isn't in the parts of the body that are changing on the outside. Nope. It all starts in the ultimate control center, the brain. It's all about this incredibly well-organized, invisible cascade of hormones.
Okay, this whole operation is run by something called the HPG Axis. Now that sounds complicated, but just think of it as a three-step chain of command. First up, you've got the big boss, the hypothalamus in your brain. It sends out an order, a hormone called GnRH. That order goes to the middle manager, the pituitary gland. The pituitary then sends out two messengers, LH and FSH. And those messengers travel all the way down to the factory floor, the gonads, the ovaries or testes, with the final instruction, all right, time to start making sex hormones.
And these sex hormones, like estrogen and testosterone, are the real stars of the show. They are the chemical messengers that zoom through your bloodstream, delivering super specific instructions to different parts of your body, telling them, hey, it's time to grow, time to change.
So, what do these hormonal instructions actually build? What do they do? Let's trace the typical timeline of transformation, and we'll start with the changes in females, because there's a very common sequence of events.
The process usually follows a pretty predictable path. It typically starts with something called the Thelarche. That's the beginning of breast development, somewhere around ages 9 to 10. Soon after that, Pubarche, or the growth of pubic hair, begins. And then, usually about 2 years into the whole process, comes the big one, Menarche, which is the first menstrual period. Let's zoom in on that very first step, the Thelarche. It's a really big deal, because it is the very first visible sign that puberty is officially underway in girls. It starts with what are called breast buds, and this change is driven entirely by those rising levels of estrogen coming from the ovaries. Now, here's something that might surprise you about pubarche, which again is just the growth of pubic hair. We always think of testosterone as the male hormone, right? Well, it's actually the key hormone that kicks off this specific change in both sexes. Pretty cool.
And finally, we have menarche. This is, of course, a huge milestone marking the beginning of menstrual cycles. But it doesn't happen right away. It usually shows up about 1.5 to 3 years after that first sign of breast development.
All right, let's shift gears and talk about the parallel journey for males. The hormonal commands deep inside the brain are pretty much the same, but as you'd expect, the timeline and the physical results are very different. For boys, the very first sign is an increase in testicular size. This is because the testes are starting to ramp up production of sperm and testosterone. Pubic hair growth usually starts around the same time. Then, about a year later, the first ejaculation can happen, which is then followed by growth of the penis and, of course, the classic deepening of the voice.
And of course, there's the one experience that's pretty much universal, the famous growth spurt. That sudden period where you feel like you're growing an inch overnight, it's not just one thing causing that. It's a complex team effort between the sex hormones, growth hormone, and another factor called IGF-1, all working together to make your bones grow like crazy.
And this is a really significant biological moment. In the same way that menarche signals the start of menstrual cycles for females, the first ejaculation marks the point where a male is theoretically capable of reproduction because the testes are now actively producing sperm. Of course,
not everyone's internal body clock follows that exact schedule. Sometimes, puberty can start way earlier or way later than average. And when that happens, these variations have actual clinical names.
And the definitions are really specific. It's called precocious puberty when signs start to show up before age 8 in girls or before age 9 in boys. And on the flip side, it's considered delayed puberty if there are absolutely no signs by age 13 in girls or by age 16 in boys.
So when puberty is delayed, doctors have to become detectives. They have to figure out where in that chain of command the communication broke down. Is it a problem with the boss in the brain or with the factory on the ground floor? Well, the levels of those messenger hormones, LH and FSH, give them the answer. If the brain isn't sending the signal correctly, the messenger levels will be low. That's hypogonadotropic. But if the brain is sending the signal just fine and the gonads aren't listening, the brain basically panics and starts shouting, sending more and more signals. That leads to high messenger levels, and that's hypergonadotropic. It's a really clever way for doctors to figure out the root cause.
So, when you step back and look at the whole picture, from a single tiny command in the brain to this huge cascade of hormones that reshapes the entire body, puberty is a universal human experience. And yet, as we've seen, the timing and the sequence can be so different for each person. Which leaves us with a final thought to chew on. What does all this variety in one of our most fundamental biological programs really tell us about the beautiful complexity of human diversity?